Hi Katie, thanks for sending your question. So we have two steps that are going to enable us to figure out what the graph of this function right here looks like. The first thing we're going to do is examine the leading coefficient. The leading coefficient is a fancy name for the number, including the sign of the number, in front of the x that has your largest exponent. In this case, it would be the x cubed. So the number in front of the x cubed, because it doesn't really show up, we can tell is a positive 1. Now you see I have some sketches already kind of mapped out up here for you. Let's look at the graph of just a regular x cubed function. It's not a very good picture, but what we want to really look at is what's called the end behavior. So if you have a positive number in front of x cubed, or positive sign, as x gets bigger and bigger and bigger on the positive side, y is going to get bigger and bigger and bigger on the positive side. And we're going to have the same thing going on the negative side. As x gets more and more negative, y gets more and more negative. Now, let's contrast that to negative x cubed, which actually has the opposite thing going on. As x gets bigger, y gets smaller and smaller and smaller, and as x gets smaller and smaller and smaller, y gets bigger and bigger and bigger. So we can tell, because we have a positive 1 in front of this x cubed, that our end behavior is going to correspond to this picture. So we can eliminate b, because we can see that that's end behavior that would correspond to negative x cubed. We can also eliminate d, based on the fact that we know this is a cubic function and not a quadratic function, and this is the graph of a quadratic function. So we're left with a and c. To figure out which one it is between those, we're going to go ahead and we're going to factor this function and set it equal to 0 to find the intercepts. So let's go ahead and see if we can factor out any monomials. We can. X cubed and negative 4x both have an x in common. So let's go ahead and factor that out. We're left with an x squared as our first term and a 4 as our second. Can't factor x anymore, but we can factor x squared minus 4. We can utilizing a special technique because this is a difference of squares. You may have heard that before. Let's go ahead and rewrite this as a difference of squares, meaning both of these will have squares next to them. So x squared minus 4 is the same as saying x squared minus 2 squared. So because we know this is a difference of squares, and a difference of squares will factor into this number plus this number, not including the squared, that's why we rewrote it as a square, times this number minus this number. So our first number, or letter in this case, would be x plus this number, 2, and it will be this letter minus this number. So we have our function completely factored now. Let's go ahead and set it equal to 0. And we're going to solve for each of these factors equal to 0. Meaning we're going to solve for x equal to 0, x plus 2 equal to 0, and x minus 2 equal to 0. First one's pretty easy. We're going to subtract 2 from both sides in the second equation to get x equals negative 2, and add 2 to both sides in the third equation to get x equals positive 2. So your x-intercepts are going to be 0, negative 2, and positive 2. Let's go ahead and take a look at that picture again. And it looks like A is the only one left that corresponds to the information that we have about this function. It corresponds to its end behavior, and it corresponds to its intercepts. Thanks again for your question, Katie.